All righty. Yeah, I guess I don't need the hat on. Lesson 21, gonna do the first 30 problems. They should be easy peasy, as Yasser would say. You've done them enough, but you do want to overlearn what you're doing, just so that, somebody says 3 times 5, you can say 15 without thinking. Trying to get to that point with these problems. And it does take some concentration. Sometimes you get tired and you get, you get a little careless, but that comes with volume. All right, so don't let it bother you. Just, look at the correction and smooth out those pathways so can think a little quicker mathematically. All right, so can I see what I'm after? Yeah, not the greatest. Let's see. Rennie a little bit further down. All right, so this is mostly going to be mechanical practice. I'm not going to explain things. It's been done numerous times in the first 10, 15 lesson sets. So lesson 21, 1 through 30 coming your way. Equation of a line, I see -2/7, so I'll write y equals x plus 2 plus 7. I'll try to be not careless. -2 to 10 is a change in x of 12, linear change of 12. 7 to 0, going down 7. And I got my eraser with me, and I've got, well, let's leave that there. I don't have any reason I can't leave that there. Slope-intercept form. So that's going to be y equals 2/5 x. Now I've got -8/5. And I have to have fifths. So 80 is 40/5. 40 minus 8, 32/5. So I'll put that answer here, 32/5. So if you want to do the problems and then just, scan forward, you can just check the 5 answers. Name 3 coordinates. Well, I can see a 4, and I like to do the x column all at the same time. I'm changing by 5, 9 and 14. And then I've got a y value of 8. When I use a 4, I can see a 4 getting me an 8. And I'm changing by 2. And it doesn't hurt to drop in the 14 and to see if it comes out as a 12, just to check for carelessness. So I was very careless on my last answer key. I didn't, of course, then again, I had to do it mental math and I didn't have time to check anything. So it was about a 20-minute burst of responses, and I made my fair share of careless errors. So I'm trying to be a little more careful today. All right, so we got 5 into 10, 2 times 2 is 4 plus 8 is 12. You move on. So we're on problem number 3. We just did 3. That was the coordinates. So now number 4. Number 4, if I don't see zeros and zeros, I know you haven't really been paying as close attention as you probably should. All right, so if I let x equal 0, I got my y-intercept -29/7. And if I let y equal 0, I got my x-intercept 29/3. In other words, that information comes from this line of work without having to think. And that's why it's called the graphing form. Because you basically have everything you need to graph, 2 points to graph a line, and you get your 2 coordinates very quickly. So I'm looking for 0, 0, and if I don't see 0, 0, and the numbers that go with it, deduction. Getting close to those midterm grades. All right, so different ways to do this. I don't know why I wrote 2/2. You certainly could, in your mind's eye, make that a -x. And I still think it might be useful to just multiply by 5 and get rid of the fraction. So if I multiply by 5, I've got -3x minus 5 equals -5x. Then I can see my x answer. I can just do it mentally. Bring the 5 over, you got 2x, bring that 5 over, so you got 5/2. Okay, and what did I do? I multiplied by 5, the 5's cancel, -3, 5's don't cancel, -5, nothing cancels, -5x. Bring the 5x over, there's your 2x, there's your 5, there's your 5/2. All right, moving right along. So some of those you don't have to put pencil or pen to paper. I should be using a marker on your desks or a pencil. So what am I going to do with this? Well, this is a line that's going up. This is a line that's coming down. I'm trying to find the point of intersection. That's what we're trying to find. So I'll make this -6y so I can cancel that column. So I'm going to multiply the top by +3. If I multiply that by 3, I get 9x, that by 3. And, eventually you don't even write that. You know the y's are going to cancel. But 3 times 9, 57. And then I got the bottom line, 2x plus 6y equals -2. So there's 55. There's 11x. There's x equals 5. And once you know x equals 5, put it into the easier. Which one's easier? I guess maybe the top one's easier. I don't know. 3 times 5 is 15. I think this one would have been easier because I don't like dividing by a negative, and I don't even want my brain thinking about moving it. So 2 times 5 is 10 plus 6y equals -2. So -12, 6y equals -12. So therefore y is equal to -2. And then you can check it in the other one. 15 plus 4 equals 19. Okay, no carelessness. Problem number 6, the intersection is at 5, -2. Kind of a tedious problem. Well, I wasn't going to erase, but I just did. All right. So that's 6. F of x equals 2x plus 5. We're going to do f of -3/7. -3/7 means we're going to take 2, multiply by -3/7, and then add 5. So there's -6/7 plus 35/7 is 29/7. Hopefully you're getting better and faster and fewer errors as you go along. F of x equals -3/4. Well, that's f of x. The calculation, 2x plus 5, we want to know when it equals -3/4. So multiply by 4 gets you 8x plus 20 equals -3. So 8x is equal to -23. So x is equal to -23/8. So 8, -23/8. Number 9, f of x equals 5x plus 1. Find f of x. So f of x is equal to 5x plus 1. And we're doing f of x. Well, there's another name for f of x. I hope you can spot it. It's 5x plus 1. And that's what I'm going to plug into the gateway. That's the entry passageway for whatever I want to evaluate. And now I want to evaluate 5x plus 1. And if you give me a number, we can work numerically, but we're working algebraically. And final answer, 25x, 5 plus 1, 6. So 25x plus 6. If you're working on your own and coming back to this, that's the answer you want to get, unless I'm making a careless mistake. 64x cubed plus 27y cubed. 64x cubed plus 27y cubed. I'll do that with just the numbers first. 64 and 27. 4 and 3. Those are the cube roots of 64 and 27. And then I work with those numbers. 16 and 9 have to show up in order to get those numbers. But I need cancellation here. Otherwise, I get all kinds of middle terms. And the cancellation's -12. All right, so I think the quickest way, well, I want to show the foiling here. So 4 times 16, 64, -48, plus 36. 3 times 16, +48. 3 times -12, -36. 3 times 9, 27. I hope you can see the cancellation in the middle, getting us 64 plus 27. Now, how does it change when we start using variables? No, it doesn't really. It's just the cube root. The cube root of that is that. Cube root of that is this. And then we build this parentheses. I might as well do it right here. Problem number 10. Save me writing it again. Well, except I did a bad job of writing 10 there. 4x plus 3y. The next parentheses should be 16x squared. We got to get back to the cubic. 64x cubed, right? So maybe I should write it here. 64x cubed plus 27y cubed may be written as 4x plus 3y, 16x squared. That gets me the first term. The cancellation is -12xy. And then what gets me back to 27y cubed? Well, I got a 3. I need a 9. 9 times 3 is 27. I got a y. I need y squared to get to y cubed. So perfect cubes, any multiple of 3 can be written as a very user-friendly cubic. All right, so I just did that problem. That's problem number 10. And now we're moving along, Renee. What's the range of this sinusoid? Well, we, again, have not started doing our unit circle work. To a pi over 3. What's the sine of pi over 3? We haven't covered that yet, but we have covered that the hypotenuse of this is 1. We have covered that if this was root 3 over 2, and this is 1/2, which is what the ratios are for that angle, which is the same as saying 60 degrees, but it's a 3.14 divided by 3, a little more than 1 radian. 1 radian is approximately 57.3 degrees. All of this is important to know. Not that many people do. I think it's important to know, so I'll just keep saying it because the more times you hear something, the better chance you have long-term memory. All right. So what's the biggest the heights can get? Because a 30-degree angle has the same ratios, except that's the half and that's the root 3 over 2, and that's going to be covered in the Intro to Unit Circle video, which I keep telling you to watch before we get here. So back again, sine function measures height. In a unit circle, the biggest height is 1 and the smallest height is -1. And I don't care how fast you run around the circle. You can go slowly around the circle. How do I go slowly around the circle? I cut my rate in half. If I'm going half as fast as you, it's going to take me twice as long. Whereas if you're going twice as fast as me, woo, you're going to get that period very quickly. All right, so when I look at a problem like this, sine 15, sine 7x plus 31, I know 31 is the center of the circle, right? The center for the parent function is 0. It's now 31. Instead of going up and down 1, we're going up and down 15. So the range of this, problem number 12, I think I might have missed 11. I'll come back to it. This function is multiplying 15 times plus and minus 1 plus 31. So what's the biggest you're going to get? 15 on top of 31 to 46. What's the smallest you're going to get? 15 from 31, which is what? 15 from 31 is 16. So the range, problem number 12, I think I'm doing problem 12. I don't know where 11 went, is y is less than or equal to 46, greater than or equal to 16. That's the range. And now I came so prepared. This is the first time. This is time to celebrate. Number 11. What is the range? Oh, okay. So I misnamed it. That was problem 11. Now, problem 12. Let's get rid of this conversation. Right there. Yep, I hear that. I hear all those words going away. Get rid of that. Center and radius. Still got a problem here. Oh, well, 12. Oh, that's the one I didn't write. Problem 12. And problem 12 was 2x squared. 2x, well, my numbers are a little off, but who cares? 3x minus 7. God, I have trouble writing the number 3 all these years. 3x minus 7. Don't know why. Minus x squared. I should actually stop and think about that. X squared, 5x plus 2. But with retirement around the corner, I don't think I will. 2x squared times 3x is 6x cubed minus 14x squared. And I like columns because we're going to be doing more than distributing through 2 terms here. Minus x squared times 5x is minus 5x cubed. Minus x squared times 2 is minus 2x squared. So what does that answer become? And I think it's problem 12, actually. X cubed, adding these columns up, minus 16x squared, piece of cake. All right, now we're looking at 13. 13, let's clean this board up a little bit. There we go, 13, problem 13, center and radius for X squared, I think I can erase this and do the problem right here. Save a little bit of time. So what's another name for x squared minus 20x? I could have called it x minus 10 squared, oh, excuse me, x minus 10 parentheses squared minus 100. It's another name for this. And there's another name for y squared plus 4y. Y plus 2 squared minus 4. And that's equal to minus 4. So I can get rid of those, and bring over minus 100 to the other side. And I got a nice Pythagorean triangle. X minus 10 squared plus y plus 2 squared. So what do I have? I've got a circle centered at 10, negative 2. And this has been discussed in plenty of the lesson sets prior to this. And the radius is 10. So when I draw triangles, right, that is now the x minus 10 axis. Here's the x-axis starting at 0. If I erase 10 units, maybe I can call that the x minus 10 axis. So I get new axes, and the radius is also 10. I don't like the same number showing up anywhere, but it did. It showed up twice. So the center was 10, negative 2, and the radius was 10. All right. Let's get rid of this. Yeah. I want the inverse of 3e to the x plus 2. So the inverse starts with x, which happens to be the outputs of this equation. And so if I want to solve equations, what would I do? I'd subtract 2, I'd divide by 3, and the inverse of e to the, and here's the, is the ln of, I guess that's all I can say is the ln of. Well, this is my of. So that's the ln of. Now, how do we check that? Well, with some simple numbers. And if you don't know the ln of 3, I don't know if you've been in the class. If you're not saying 1.1, I have to question you if you've been here for the amount of times we said that. So I trust everybody knows that. So if I put 1.1 in for E, I get 3 times 3, I get 11. Which means if I put 11 in here, I should get the ln of 3. 9 divided by 3 is the ln of 3, and that's 1.1. So that is correct. In case I'm looking for careless errors, and I am now. I made too many the other time. All right, so that was 14. X minus 2 over 3 ln of. That's a button on your calculator. Tells you all the exponents that you put on top of E to get, for instance, 77. What's the exponent I put on top of E? 2.71 to the what gets me 77? You go to your calculator, you find the ln button, you put 77 in there, and it'll tell you. And I don't know what that number is, because I don't know the ln of 7 or 11. 2x cubed plus 5. Well, the inverse of some function is 2x cubed plus 5. Then what was that function? I got to subtract 5. I got to divide by 2. I got to undo cubing, and I do not need plus minus there. All right, x cubed looks like this. The cube root of x looks like that. Okay, when I draw a line through, I get one answer, unlike the quadratic where I get 2. Okay, so that's your final answer. Cube root of x minus 5 over 2. Early in the term, I wasn't surprised to see plus minus. Don't want to see it now, though. Talked about it a bunch. All right, vertex. So the first thing I'm going to do is remember minus b over 2a. Got to know that. Minus 40 over 2 times 4. Sure looks like negative 5 to me. So I'm going to put negative 5 into the function, and it better give me a 2-to-1 ratio here. 5 squared times 4 is 100, minus negative 5 times 4. No, negative 5 times 40, excuse me, minus 200, minus 7, There's the 2-to-1 opposite ratio. I know this number is correct, so minus 107. So the vertex, the answer for that was -5, should get you minus 107. 17. Vertex, 0, 0. Well, that's just y equals x squared. I know that is the vertex of y equals x squared, 0, 0. So might as well just write it. Now, what happens when you put a 5 in? And you want to get a 12 out? You want 12, 5 squared. I guess I got to get a multiplier here. Sure looks like it's 12 over 25. So what do I learn from that? Well, from 0, 0, for x is 0 to 5, I changed by 5. And yet, what's in the denominator? 25. Why? Because if I have x minus 0 squared and I drop a 5 in, I get 25 units, and 25 plus 0 is not equal to 12. But if I divide that number and turn it into the number 1, 1 times 12 is 12. So rise over run squared, as measured from the vertex, is the multiplier for a quadratic. Hope that means more to you now than it did 2 months ago. I hope that's coming into clearer view. I know, Yasser said he flies planes and stuff, so we got to have good vision. Yeah, good vision right there. All right. We're talking about vision in comments there the other day. Hyperoptic, you got me with that one too. 18, 5x squared minus 15. So therefore, x squared equals minus 3. X equals plus minus gets you half a point. The square root of 3, I don't care about. I didn't even bother to write the square root on my last answer key. Talk about careless. But that's really the square root of -3 at the moment. So what am I looking for? The letter I and an eraser. So let's actually check that. 5 times plus minus the square root of 3i. Let's see what we get. Plus minus gets squared, becomes positive. Squaring a square root gets you what's inside. Squaring I gets you I squared. What does I squared do to 3? Makes it -3. And 5 times -3, lo and behold, is minus 15. So I need the plus minus, I need the 3, and I need the I outside of the radical symbol. 19. 4x squared minus 8x equals 0. Let's see if we've closed those gaps from Algebra 1. I always just take out x. I don't care if it's the least, if it's the greatest common factor or not. I just like taking out x for a problem like this. And I got 4x minus 8 equals 0. I like students to have to look at that and go, oh, x could equal 2. Add 8 divided by 4. Or x could equal 0. So we're looking for x values that are either 0 or 2. I think you should check your answers from time to time. Let's put a 2 in. If you're not working with numbers, you're not getting a feel for a calculation. 2 squared, 4 times 4, 16, minus 8 times 2, 16. Yeah, 2 seems to work. If I put a 0 in, it looks like 0 minus 0 gets me 0. I guess that works too. All right, 20. 9i to the 50th. 9i to the 50th. Again, the textbook would use a pattern of 4. I think it's much more beneficial for students to have to work with I squared, which is a sign change, 25 times. That is the same thing as this. What's another way of writing that? 9 minus 1 to the 25. And what's another way of writing that? 9 times -1. And what's another way of writing that? -9. Notice there was something really important in all of that. Changing the name of something to an easier name. That's half of what we do in math, is simplify. Try to simplify things. Wish life was so easy. All right, 5 minus 3i squared is 25 at the beginning, positive 9i squared at the end, but don't forget to double the middle product, minus 30i. So what does that become for problem 21? 25 minus 9, 16 minus 30i. 22. Let's just square it. It's got a little bit longer answer. So square the first term, 16a 10 b 10. Square the last term, always positive, and then double that product. The product is minus 20 of these things. Minus 20 of those. I'm going to double it and make it minus 40 of those. A5, B5. Now, if you want to take the time to multiply this out, parentheses times parentheses, go right ahead. But you're going to see that pattern emerge. And a big part of learning math is recognizing patterns. And if you see them and you remember them, you don't have to work so hard. I'm trying to save you time. 23. I'm going to work above here so that you can hopefully see things more clearly. I'm seeing 2 times the square root of 9 times the square root of 7 as another name for this. I'm seeing 2 times the square root of 4 times the square root of 7 as another name for that. I'm seeing 6 root 7 as another name for that, minus 4 root 7 as another name for that, and I'm seeing 2 root 7 as another name for that. Problem 24. Okay, so I didn't have this chat with everybody during our workshop, but if a fraction equals a fraction in grade school, you should have looked at this. You should have looked at, does that fraction equal that fraction? If it does, then 1 times 10 has to equal 2 times 5. That sure seems like it's true. So if you got a fraction equaling another fraction, why not just do cross products? 3x squared equals 10x. And then from previous problems, move it to the other side, set it to 0. I take an x out, 3x minus 10 equals 0. I can see x equals 0 again, and I can see x equals 10/3. And those are the roots of the parabola. So what's in between 0 and 10/3? 10/6. That's in, 5/3, right? Half of that, I should have said 5/3. Would have been easier to understand. Right? And then if I want to find the y value of the vertex, I got to plug 5/3 in here, which I'm not going to do right now. But if I have the vertex and I have the a value, and I didn't write that answer down. What was it? Oh, I got to look at it again. That's my memory. Doesn't even remember what I just worked on. I'm be in the nursing home soon. I can't even remember what problem. 23, 24. That's on the other page. We just did it. So whatever it was, it's correct. 3x squared equals 10x. 10/3, 0 and 10/3, I think it was. Then I said 10/6, which is, but yeah. So it was 3x squared minus 10x equals 0. It's coming back to me, I think. So x equals 0 and x equals 10/3. All right, good enough. That was for my own benefit. Of course, I never wrote it over here. 25. Okay, well, I know I'm measuring from 5, right? Roots are, when does it equal 0? I know it's imaginary. My roots are imaginary because 0 is not there. Boy, I did muscle memory on that one. 0 is here. A little more careful look, right? So I know my answers are imaginary, so that's got to be part of it. And I know that there's 2 sides to this. So I guess a plus minus from 5, because I'm trying to find that x and that x that give me this and this. And I guess I got to move 6 units. I guess that's it. Now, if a is 1, then I have 1 times x minus 5 squared plus 6 equals 0. I hope you can see -6. I hope you can see plus minus -6 with a square root. I hope you know from the earlier conversation that you're going to move the negative out and call it I, and then you're going to move the 5 over, and it's going to be -5. So I made a mistake there, and I just caught it. No, I didn't. No, I didn't. I'm measuring from 5, so what did I do wrong here? Oh, it's -5. I'm going to bring that over, +5. Too close to the board again. And there's our answers. All right, you can get them right from here. You don't have to do all this. If you can see these numbers, 5 and 6, and really there's a 1 here. This is really divided by 1, but you don't have to show it. But in previous problems, about half the class is doing that in 5 seconds or less. Be nice if everybody did before midterm. 36 minus 25 as a product. Well, what do those numbers have in common? They're very user-friendly. That's 6 plus 5 times 6 minus 5, which happens to be 11 times 1, which happens to be what 36 minus 25 is. It's 11. So the sum of the square roots times the difference of the square roots, and these things can get more complicated. They could even be 7 minus 2. How would you write that as a product? I hope you do the square root of 7 plus the square root of 2 times the square root of 7 minus the square root of 2. Okay, so now we've got an equation here. So that was 6 plus 5, 6 minus 5. I want to keep those answer keys going. So now we're on 27. Well, 1 plus 8 is 9, 4 plus 2 is 6, and 3. All of those numbers are divisible by 3. So the first thing I'm going to do is divide this by 3. And if I do, I get x squared plus 6x. I get 14, but I'm going to bring it to the other side. Okay. Now what? I don't see factors of 14 that add up to 6. Does that mean I'm done? Well, you got a choice. You can either go the quadratic formula right now, or you just complete the square, and you can do completing the square mentally if you want. So what are you going to get? You're going to get minus 9, minus 4, minus 23. It should show up this side with a plus minus, and I said x plus 3, so we're measuring from minus 3. Let's see if that's true, because I'm near the end of this video, which means I'm ready to make my mistakes. So what I thought I saw was this. That is 9 and 4. Yeah, it's 23 on the other side. And then I got the plus minus. And then I got positive 3 goes the other side and is negative 3. Looks good to me. Factor. I am going to erase here. But I can get that answer right here. Minus 3 plus minus the square root of 23. I can at least write that. All right, so what are the steps in factoring this? Well, the first steps are write what you know has to be true. Don't keep it in your head. Then look at the fact that whatever that number is, it's 7 times bigger. So I want a factor of 10 that gets me to 33. I'm seeing 5. And I want a plus. I hope this works. Oh, minus 2 times. Yes, it does. So 28. 7a minus 2 times a plus 5. 29. Almost done. I'm seeing bingo, bango, bongo. Now I'm seeing bingo, bango, bongo. I'm going to do this over this. 2 times x minus 2, 2x minus 4, x plus 5 times 3, 3x plus 15. And then I've got whether or not I want to multiply it out, doesn't matter to me. You can leave it as x plus 5 times x minus 2 on your test. I don't care. But 2x minus 3x is minus x, and minus 4 minus 15 is minus 19, and x plus 5 times x plus 2. If you want to multiply it out, just don't make a mistake. 5 minus 2, 3, yeah, negative 10. See? Mistake. I had the numbers 2 and 3 in my head, or something else. I don't know. So that looks good now. And the last one, distance. Okay, well, let's just look at negative 6 to 4. Those are the x's. X equals negative 6 to 4. I think I have 10 units of linear change. I think that's a line. I got a 7 to an 11. So I got a y equals 7 to a y equals 11. I think that's 4 units of change. So I think I've got 100 square units and 16 square units. I think I have 116 square units. So this length is the square root of 116. All right, hope I didn't make any mistakes. I got help if I did, which is I'm very grateful for. Volume, high volume here. I start written 3 tests today, 2 answer keys, and just made a video and gets a little shaky. I probably should do the video early, but I gave up coffee. So then I'm coming in the morning. All kinds of problems. God almighty. Retirement, 2 months away. I'm gonna miss being in here, don't get me wrong. But I'm also starting to, the cognitive decline continues. All right. Well, it's actually a nice warm day here today. If you're not in a nice warm place, try to stay warm. Okay, bye-bye.